Assalamualaikum and good day. In this video, we are going to look at phase diagram. First thing, we must know what is phase diagram. It is a graphical representation of what phases are present in a material system at various temperature, pressure, and composition. So why we need to know about phase diagram? It is because there is a strong correlation between microstructure and mechanical properties. Besides, development of alloy microstructure is related to the characteristic of its phase diagram. Normally, phase diagram is important for casting and soldering process so that we will know what is microstructure that will be produced, and from that microstructure we can determine its mechanical properties. Generally, there are three types of phase diagram. The first one is unary phase diagram. It consists of one component in an alloy. Example of unary phase diagram is shown in this slide. The second one, we have binary phase diagram. It consists of two components in an alloy. In this video, we are going to focus on binary phase diagram. And then the third one, we have ternary phase diagram, which consists of three components in an alloy. You can look at example of ternary phase diagram in this slide. What do we need to know about binary phase diagram? The first thing is binary phase diagram consists of two components in an alloy. It means that we have one host atom and another one impurities or element. For the binary phase diagram, we will cover on three types of binary phase diagram. The first one is complete solid solution, or we call it as binary isomorphous solid solution. And then the second one, we have no solid solution. And then the third one is limited solid solution. For the complete solid solution, it means that the two elements will form a single phase solid solution. For example, over here we have copper and nickel. They are completely soluble. And then for the no solid solution, we have plumbum insoluble in copper. It means that after we combine them together, we will see two elements in the solid solution of plumbum and copper. Under the microscope, we will see they are not mixed together. And then for the third one, we have limited solid solution. For limited solid solution, it means that the impurities can mix together in the host element for certain extent. For example, over here we have SN has limited solubility in Pb. So only a certain percentage of SN can be put in Pb where they can mix and form single phase solid solution. After that solubility limit, we will see the separated element in the solid solution. The three types of binary phase diagram is explained better in this slide. To understand complete solid solution, we can use the example of complete liquid solution like alcohol and water. When we mix alcohol and water together, Doesn't matter how much the percentage of alcohol and how much the percentage of water, they will mix well together. So we call it is complete solubility in liquid and solid. Their complete solubility is in liquid, and if we cool them down, it will become complete solubility in solid also. It is result in single phase either in liquid or in solid. The example here we have copper and nickel. And then the second one for no solid solution, we take example as oil and water. When we mix together oil and water in a cup or in a bottle, and then we stir it well. After we wait for a while, the mixture will form two layers. On top layer will be oil, and then the bottom layer will be water. It is result in multi-phase. It doesn't matter in liquid or in solid. The example is Pb and copper. And then the third one, we have limited solid solution. For example, here we have pepper powder and water. And previously, the example is on hot chocolate. For pepper powder and water, it is often soluble up to limit. At certain percentage of pepper, you can see the pepper powder will mix together in the water. After certain percentage of pepper powder added, it will not dissolve in the water anymore because the percentage of water is reduced with the increase of pepper powder content. It will result in multi-phase. The example given here is zinc and copper, Sn and Pb. So that's all for this video. Thank you. Have a nice day.